In the first one is asking us for the volume of the water that is equal to 100 millimeters cubic of gold. I use the formula volume is equal to mass over density. The mass of the gold is equal to 0.0093 over 1000, which is the density of the water. Then I use the formula mass is equal to density times volume. The density of the gold is 19.3 times 10 elevated to 3, and it is multiplied by the last volume. The result is 0.00193. In the second one is asking you how the pressure of the submarine is maintained while it is submerging. It's asking of the pressure and the force applied to a hatch 1 meters wide and 1.5 meters long. I use the formula pressure equal to density times gravity times height. The density of the water is 1030 times 9.81, which is the gravity, times 200. The result is 2860 pascals. Then I use force equals to pressure times amplitude. The pressure is the previous one times 1.5. The result is 3,3190 newtons. In the third one, it's asking us for the force to lift a truck that its mass is 1,300 kilograms. The first one is 30 millimeters and the second one is 75 meters, and we pass this to meters. I use the formula force 1 over area 1 equal to force 2 over area 2. The first area is past multiplying because we only missing the fourth one. Since area 1 is equal to 0.002728 and area 2 is 0.01765 and force 2 is 2765, giving the result of 2042.6478. In the fourth one, it's asking us for the pressure that is used to lift a crane that its mass is 2,300 kilograms, giving us two radius that is always we pass to meters. The first radius is 30 millimeters and the second one is 64 millimeters. First I use the formula force equal to mass times gravity. We have both. The result is 22,563. Then I use the formula pressure is equal to force over area. We use the last force and the second area of the 64 millimeters, which is 0.0128679 meters. The result is 1,753,432.961. On the fifth one, we are talking about a balloon that where its density of the top where it is 0.9 kilograms over meters cubic. It has a volume of 20 meters cubic and the helium's density is 78 kilograms over meters cubic. It is asking how much mass can the globe withstand. We use the buoyant formula, which is volume times density times gravity, which will be 0.9 times 20 times 9.81, and the result will be 176.58. We rest that to the weight and it is divided by the gravity. The last result is 8.4179 kilograms. The sixth one is another balloon asking us again how much mass can the globe withstand, giving us a radius of 21 meters and a mass of 500. Also, a density of the air is 1.22. First we get the weight, which is mass times gravity. The result is 490.2, and we get the volume with volume equals to 0.75 times pi times radius cubic. The result is 21,820.71, and we multiply it by 1.2 times the gravity divided by the weight. The result is 523.69. On the next one is asking us how much time it takes for a tank to fill, giving us the velocity, which is 3 meters over seconds, a radius of 0.02 meters, and that the tank is 20 liters deep. But 20 liters in meters cubic is 0.02. First, we use the formula of the flow rate, which is the velocity times area. The result is 0.003678. But in liters per minute would be 22.6.1946. Then we use the formula to get time, which is velocity over the flow rate. The last result is 5.43. The next one is another tank, but it's asking us the flow rate of a crack. The crack is 5 meters below, and the area of the crack is 20 millimeters square. Converted in meters would be 0.00002. So we use first the formula to get the velocity, which is the square root of 2 times gravity times height. The result is 9.9045. Then we use the formula of flow rate, and the result will be 0.000198 meters over seconds. On the last one, it is asking us for the volume of the water that leaks in a hole in another tank. It's giving us the radius of the hole, which is 50 millimeters, so the area is 0.0078. The time is 5 minutes and is located 4 meters below. We first get the velocity with the formula we've already used. The equation will be velocity equals to the square root of 2 times the gravity times 4 meters, and the result is 78.48 meters over seconds. Then we get the flow rate. The equation will be 78.48 times the area, and the result will be 0.6163. Finally, we use the formula to get the volume, which will be the volume equals to the flow rate times the time. And then the final result will be 3.0818.